Okay, so in this lesson we're going to carry on with what we did in the previous one for 6-1. And what we were doing yesterday, but it wasn't expressed specifically, was we were writing our answers in what we call standard form. You want to make sure that you get this down in your notes. That standard form is in the form ax squared plus bx plus c. So if a problem asks you to write your answer in standard form, that you put it in the correct order. Now let's look at a problem like this one. Today we're going to focus on all story problems and how to apply what we were doing yesterday. So here it says Hector and Francisca are remodeling their kitchen. They purchase a 6-foot by 2-foot pantry door and are looking at different widths of molding to trim the door frame. If the trim is W inches wide, write the total area of the door and trim in standard form. A couple of notes here. First off, our units always have to be consistent. So if our trim is going to be measured in inches, that means we want to change these measurements, our 6-foot by 2-foot pantry door, we want to change those dimensions to be in inches, which they've done for us in this diagram. But a lot of times with what we're going to be doing today, they're not going to give you a diagram, so you just want to make sure again that your units are consistent. Secondly, if we hadn't had a diagram here, you'd have to create your own. And a little bit about molding. It goes around the door, but obviously you're not going to have molding along the ground because you're not going to want to trip over it. So in this case, our molding just goes around 3 sides of our rectangular door. And the key here is they're asking us for the total area. I'll talk more about that in a second. Now first off, if we want to know the total area, we want to know what the total dimensions are for each side. Well, I know the door is 24 inches wide, and we're going to have W inches that we're going to add to either side of it. So I'm going to write that as 2W plus 24. Where do I get the 2W from? Well, I know that this width here is W, and I know this width here is W. So W plus W is 2Ws plus 24, which we know the width of the door. So we 2W plus 24. The width, or the height of the door, is going to be, well, it's just W plus 72. Because I only have one W. I don't have a W on the floor, I just have a W on the top, plus the height of the door, which is 72, so it would be W plus 72. Now, here's what I want to get at. Total area is not finding just the dimensions. This is not my answer. If I asked you for the area of our classroom and you said our classroom was 22 feet by 30 feet, that's not the total area, that's just the dimensions. So make sure when they ask you for the total area that you do multiply these together. Now you could use that traditional method that we talked about yesterday, or we could use this newer method that I prefer, which is the window method or the box method. So I'm going to put the W plus 72 on top and the 2W plus 24 on the side. Now when I multiply these together, 2W times W is 2W squared, and 2 times 72 is going to be 144, so that'll be 144W. And 24 times W is 24W, and 24 times 72 is going to be 1,728. So now again, we combine like terms. Your like terms are going to be the diagonal ones there. They both have just plain old W's. I don't have any other W squared, so leave that 2W squared as it is. And then 24W plus 144W is going to be 168W. And then plus the 1,728. Now a couple of notes on this. Sometimes they'll say find the total area if the door frame had a width of 2 inches. In which case now we just have to put 2 in for W and we'd have the total area of the door with the frame if the frame is only 2 inches. Now sometimes they ask you for what's the area of just the door frame. Well, we know the area of the door is 24 by 72, which is, well, if you look at our table, 24 times 72 is 1,728. So if they had asked me for what is the area of just the frame, we would take out the area of the door, which is the 1,728. So the area of the frame would just be 2W squared plus 168W. So make sure you understand that for some of these story problems we'll be looking at. Well, let's look at this one. This one here, they give us a description, but they don't give us a diagram. So we're going to have to create our own. It says a portrait is 20 centimeters by 90 centimeters. A frame around the portrait is F centimeters wide. So let's stop there. I notice that all my units are in centimeters, so I'm good to go. They're not trying to trick me here. Write the total area of the portrait and the frame in standard form. So let's just draw a diagram here of what we have. So we're going to have a picture. That's 20 by 90 centimeters wide. I'm going to put a frame around that picture. Oops, not the best part there. Let's see if I can get that better. There we go. Okay, so the frame is going to be W inches wide. So that means on all four sides, it's going to be the same width. Okay, so now I have to come up with my new dimensions. My base and the height. My base is going to be, well, I have this width and the width of my picture. So it's going to be 2W plus 20. The height, well, I have this width and this width, so that's 2W plus the height of the picture, which is 90. Okay. So I actually want you guys to pause the video, and I want you guys to work the rest of this problem out. So practice what we did in the previous lesson. So find out what the total area of the picture with the frame would be, and hit play when you're ready to check your answer. Okay, let's see how you did. So I'm going to put 2W plus 20 here and 2W plus 90 here. Multiply these together. Well, 2W times 2W is 4W squared. 2W times 20 is 40W. 2W times 90 is 180W. And 20 times 90 is going to be 1800. Combine like terms, so these two are going to add together. So it's going to be 4W squared plus 180 plus 40 is 220. 220W. Plus 1800. So that's a total area of the frame with the picture. Now, when it says what is the area of just the frame, the 90 times the 20, remember that part there gives you the area of the picture, so that's 1800. And that 1800 I don't care about. I want just the area of the frame. So I take away that 1800, so it's going to be 4W squared plus 220W would give me the area of just the frame. Okay, now I want you guys to try this one completely on your own. So start out by drawing a diagram for the story problem, and then use that diagram to come up with your new dimensions, and use those dimensions to find the total area of the pool and the walkway, and then find the area of just the walkway. So pause the video, work this problem out, and hit play when you're ready to check your answer. Okay. So this one we have a swimming pool that's got dimensions of 20 feet by 42 feet. Okay, so there's our swimming pool. And they're going to put a walkway around the swimming pool that, let me put these numbers inside. So we're going to put a walkway around it that's also measured in feet. And that walkway is going to be W inches wide on each side. So W plus W is going to be 2W plus 42. And then I'm going to have 2W plus 20. So again, these are just my dimensions. The 2W plus 42 by 2W plus 20 are my dimensions. The area, though, is when we actually multiply these together. So what you should have done is multiply those again. You don't have to use my window method. If you're more on the traditional side, you can use that if that's what you have been taught before. It's just that I like this because it keeps things a little bit more organized. So again, 2w times 2w is 4w squared. 2w times 42 is going to be 84. And this will be 40w. And 42 times 20 is going to be, that's going to be 840. So now let's add these together. So it's going to be the 4w squared stays the same. These are our like terms. So it's going to be, oops, I forgot a w in there. So that should have been 84w. But 84w plus 40w is going to be, what would that be, 124w plus 840. A little note about that mistake that I just made, so I forgot to put that w in there. We all make mistakes. It's important to catch them, though. One way to catch that mistake would have been to recognize that your like terms are always going to be diagonally across from each other. And so in this case here, we'd have the 40w and the 84w, so that's how I caught that I needed a w in there. Okay, so now let's figure out the last part. It says, what is the area of just the walkway? Well, we don't need that 840 because that 840 again represents the area of the actual swimming pool. The walkway going around it is going to be the 4w squared plus 124w. Let's look at a different type of problem. What if, because with each of these, with the picture frame and the swimming pool, we had a rectangle within a rectangle, and that rectangle was centered. And with the door, even though it wasn't centered, we had a width going equally, an equal distance all the way around the other three sides. Well, what if we have a situation like this? Because sometimes maybe we're dealing with a window on a wall, and we're trying to paint the wall. I'm trying to figure out how much paint we would need. Well, we're not going to paint over the window, so there's ways to figure out how much total paint we would need. Now in this scenario, it's a little different. We have a whole bunch of x's here. Now they ask us to give the total area of each region in standard form. So the white region here, well, the dimensions of that are 2x by x plus 3. And in your assignment, you're going to have a problem just like this one. It's going to be set up the exact same way. So I'm going to start out by distributing the 2x through. So I'll have 2x squared plus 6x. So that's the area of the white region. Now, the large rectangle includes the white region. That's what they're implying. So I'm going to take the 5x plus 4 times 3x minus 2. So again, I'm going to set this up using my window method. When I do that, 5x times 3x is 15x squared. 3x times 4 is 12x. Negative 2 times 5x is negative 10x. It's important to get that negative in there. And negative 2 times a positive 4 is a negative 8. So when I combine like terms, I'm left with 15x squared. 12x minus 10x is 2x. And then minus 8. Now here's where it gets tricky. They want us to find the area of just the shaded region. Well, I want to take away from the large rectangle the area of the small rectangle. So remember, originally in the large rectangle we have 15x squared plus 2x minus 8. But I'm going to take away from that the area of the small rectangle, which is 2x squared plus 6x. Now notice how I wrote it. This is super important because I want to distribute this negative now through. So I'm actually going to have 15x squared plus 2x minus 8. That part doesn't change, but I make everything in here a negative. So it'll be minus 2x squared minus 6x. The purpose is that I want to make sure that I subtract not just the 2x squared, but I also want to subtract the 6x. So it's going to become a minus 6x. So now when I simplify this, I'm going to combine like terms. 15x squared minus 2x squared, well that's 13x squared. Done with those. Now I have a 2x minus 6x. 2x minus 6x would be minus 4x. I'm done with those now. And I'm left with just that minus 8. So that would be my final answer. So the area of the shaded region would be 13x squared minus 4x minus 8. So if I knew that maybe this was all in feet And if x was going to be 2, I'd be able to plug this in here to find the area of the shaded region to figure out how much paint I needed, if that was what the problem was asking for. So now you guys are going to do the same thing with this story problem or with this diagram. So I want you guys to pause the video and hit play when you're ready to check your answer. Okay, so first let's start with finding the area of the small rectangle, which is the shaded one this time. So I'm going to have 2x plus 5 times x minus 2. Again, put it in a window method. So that gives me 2x squared plus 5x. Negative 2 times 2x is negative 4x, and negative 2 times 5 is negative 10. So when I write this out, it's going to be 2x squared. Negative 4x plus 5x is just 1x, or x, minus 10. The large rectangle, well, the dimensions of that are 8x minus 4 by 3x plus 6. I'm going to multiply these together now. When I do that, 8x times 3x is 24x squared. 3x times negative 4 is negative 12x. 6 times 8 is 48x. And 6 times negative 4 is negative 24. Okay, so now I'm going to combine like terms and write this out. So it'll be 24x squared. My like terms are 48x and minus 12x, which gives you 36x, and then minus 24. And the white region, well, to do that I want to take away the shaded region. I want to take away the area of the smaller rectangle from the larger rectangle. So let me write it out like this. It's going to be 24x squared plus 36x minus 24. Now I'm going to subtract from that the 2x squared plus x minus 10. Now I'm going to distribute that minus through, so it becomes a negative 2x squared minus x, and that becomes a plus 10. So now when I combine like terms, I'm going to start with the 24x squared minus the 2x squared, I forgot about that. 24x squared minus 2x squared would be 22x squared. I like to cross things out as I get done with them, so that way I can focus on what I have left over and make sure that I also don't forget about anything. So now I have 36x minus x. Well, 36 take away an x is not just 36. Okay, some people make that mistake. But what we're going to do here is 36 minus x is 36x minus 1x is 35x. So I'm done with those. And lastly, negative 24 plus 10 would be negative 14. So that would have been your final answer. So hopefully you got all that. If you don't, make sure that you get your questions answered. You could always ask me or go back to any part of this video and replay it. But good luck on your assignment.